Okay, time to finish up this gravity lesson. So all we learned so far was that if you are talking about gravity, it's a very easy problem. You have acceleration downward 9.81 meters per second squared. That's all you really need to learn from last lesson. If you have that, then that's just one variable. You plug into the formulas that we learned, like d equals v naught t plus 1 half a squared, and v equals v naught plus at. Well, there's a. That's just one step of the problem. But now we're going to learn a lot of really tricky ways to use this formula and this a to solve more complex problems. They still use the same equations, but they actually require your brain, not just plugging in numbers and typing calculator and getting the answer. So we're going to check out this really cool app called SMTH, Send Me to Heaven. Unfortunately, it's Android only. iPhone users, apparently they're too entitled. They didn't realize that they would break their phones. So they all sued the company and then they took it off the App Store. But Android users, I guess they're used to having broken phones, so they weren't that bothered. So it's pretty simple. But there's a tutorial. I'll show you guys right now. Tutorial. There. Throw your phone high, catch it, share your score, check your standings. So if you have a really old phone and you want your parents to buy you a new one, here's how you can send your phone to heaven. Throw it quickly up. Don't let it spin. Don't attach a parachute to it. Don't use a rocket. And of course, catch it before it hits the ground. So I'm going to sign this disclaimer or agree to disclaimer, and here we go. Pretty simple instructions, pretty easy game. And I did it. 0.88 meters. Good job, me. Thanks. So, how did my phone figure out how high it went? Most people say, well, phone has GPS, so obviously the phone uses GPS to solve for the starting height and the maximum height, and then just use math to figure out the height. That's not true. See this 0.88 meters? This is a sig fig in the centimeter place, so it's accurate, roughly, to the nearest centimeter. You guys have your GPS on your phone. You know you're trying to go somewhere, and you're walking, and you look down, and the blue guy in Google Maps is teleporting across the road, and then it's turning and all the weird stuff. GPS is not accurate to a centimeter. So, any ideas? What did your phone do? What did your phone use to figure out how high it went? Tell me right now if you can think of what could your phone use to solve for the height it went when I threw it. The phone used its stopwatch to figure out how high it went. Psh, mind blown. Phones have stopwatches, of course. You guys probably use them for your last lab. If the phone knew how long it was in the air, it can find the time. No, if your phone knows how long it's in the air, and it assumes that you throw it and catch it at the same height, and it also assumes that A is negative 9.81 meters per second squared, which is known, your phone can, just measuring the time, tell you the maximum displacement. We'll look at an example of that real soon. But I want to go over something that I should have done last lesson, lesson 4, when we did this formula. V squared equals V naught squared plus 2AD. Okay, what if D is 0? Why am I talking about that? That's the trick to this formula, this problem. If I throw my phone up in the air and I catch it at the same height, its displacement is not the height up and the height back down. The displacement is 0. If D is 0, does that mean V and V naught are the same? Look at this formula. If D is 0, are V and V naught the same thing, the same value? Tell me what you think. Daisy, are they the same? I think so. Yeah, because if d is 0, v squared equals v naught squared, so v equals v naught. Does that seem right? No. Why not, Hazel? V could be negative. Yes. The squaring function has two answers. Any equation with a square has two answers because the square of a negative number is a positive number. Either v equals v naught or v equals negative v naught. If I solve this formula and I get v naught squared equals, I get v squared equals 25, v could be 5 meters per second or negative 5 meters per second. That has a real important physics meaning. If we assume upward is positive, then v could be 5 meters per second upward or 5 meters per second downward. I could throw my marker up at 5 meters per second, or it can be falling 5 meters per second. Those would both give me the answer v squared equals 25 meters squared per second squared. So we have to learn a couple rules to solve this tricky problem. I'm going to tell you guys these rules right now. So this is one rule. If you go back to your starting point, if d is 0, a can't be 0. A is always 9.81 in these problems. If d is 0 meters, you would think v equals v naught. That's not true. In fact, this is a really useful trick. If I throw something up in the air, it doesn't matter how high it goes and how low it's in the air. If it comes back to the same height, the initial speed upward and the final speed downward are exactly the same magnitude, opposite directions. If I throw something up at 800 million meters per second, it'll come back down, and once it reaches the exact same height it started out, it'll be falling at 800 million meters per second. So that's one rule. Another important rule, be consistent. No, okay, sub-rule, learn how to spell. Consistent with your positives and minuses. So let's say I'm doing the problem, and like I said, I got plus 5 meters per second. Well, I'll say that's upward. Upward is positive 5 meters per second. If I assume upward is positive and downward is negative for velocity, it's also got to be the same for acceleration and displacement. All three, displacement, velocity, and acceleration, they're all vectors. But we're not really going to talk about we're not going to write the direction every single time. It's much easier to just make the number positive or negative. Whatever you do, be consistent. Sometimes you make upward positive and downward negative. Sometimes you make upward negative and downward positive, which seems strange, but I'll show you guys some examples where that one makes sense. It doesn't matter which one you pick. Either one's fine. But if you're consistent the whole time between displacement, velocity, and acceleration, you'll get the right answer. I'll show you one example here, and I'll show you more examples when we come together for practice. Okay. All right, and there's 3 more rules, and they're all together. V equals 0 meters per second. When is this true? Let's say I'm throwing my phone and it comes back down. When is this true? Well, there's 3 common examples when this is true. When the phone's in my hand, oh yeah, it's true. This doesn't count. We can't. Don't think about the phone being in your hand as having a velocity 0. And also, if I fail to catch my phone and it hits the ground and stops there, people say, oh, it stopped on the ground, or it broke on the ground. V equals 0. No good. Also no good. We can only use these formulas and do this physics when the acceleration is constant. If a phone's in my hand or broken on the ground, is it still accelerating at 9.81 meters per second squared? No. So if a phone is at rest and stationary, either I'm holding it in my hands or it's on the ground after flying through the air, you cannot say it has a velocity of 0. I know the phone started out in my hand, but we're not going to say the initial velocity was 0 because the acceleration was not 9.81. We can only analyze the problem when the phone has that acceleration, so we can only analyze the problem when the phone is in the air. So the problem is really from the millisecond my phone leaves the hand until the millisecond before I catch it. That's the time, t, and that's when it goes displacement d. That's the time we're analyzing. That's what we can use these equations, because whenever a is not 9.81, then we cannot do anything. We had no idea what the acceleration is. We cannot do any equations. So when is the velocity 0? If you can figure it out, tell me right now. When is v equals 0? There's 2 times when v equals 0. When something is dropped, it starts out not moving. If I go to the window and I drop my phone out the window, it starts out not moving. Right when my fingers, the millisecond my fingers just barely leave the phone, it is accelerating due to gravity at 9.81 meters per second squared, but it has no velocity. That's the example of when v and a, of when v is 0, a is not 0. When you drop something, the initial velocity is 0. And there's another time when the velocity is 0. And it goes back to this. A positive velocity means it's going upward. A negative velocity means going downward. When, during the phone's motion, was it going neither upward nor downward? Does that make sense? At the highest point, Mr. Lamb. Wow, good job, Sage. Yeah. At the highest point. And that is what your phone uses to find the height. Because at the highest point, the phone's not going upward or downward. If it was going upward, that wouldn't be the highest point because it's going to be a higher point in a nanosecond. If it was going downward, that wouldn't be the highest point either because the phone just came from a higher point. So right at the highest point of the trajectory, right before the phone or any object turns direction and stops going upward and starts going downward, for a millisecond, a nanosecond, an instant, the velocity is 0 meters per second. Upward or downward doesn't matter. It's neither. It's stationary for like a brief instant in time. The acceleration is not. The acceleration is still 9.81 meters per second squared. But at the highest point, assume the velocity is 0. So if we know that, we can now solve this problem. I'm not going to do it with the phone because the phone, I don't want to do it in reverse. So let's say I have an amazing basketball player and he jumps in the air and he's in the air for a full 1 second. That would be super amazing, right? Oh, let's watch this video while we're at it so we can see how crazy that would be.
Man, he did a move, which is the all-time greatest move I've seen.
Magic and I were sitting there, and we were sitting right on the baseline. And when Dr. J left his feet, he didn't know what he was going to do.
When we cut him off baseline, he started walking in air. Got the ball in one hand. And we said, wait a minute, he's got to come down. There's no way he can stay in the air that long.
And he was just in the air.
It's 89-84, Sixers, and they get inside. And unbelievable, Julius Erving.
Jones with the ball, finds Julius Erving, drives to the basket, goes up and... Oh,
Cooper and I said, should we ask him to do it again? We've never seen anything like that before. It was crazy.
Doc just picked the ball up with one hand without even touching it with the other one, and windmilled this shit ball like his arms stretched from over here all the way like a rubber band.
Okay, so really cool video. Dr. J, he could jump so high and he had so much hang time, which is the time he's in the air. He would like bring his arm and shoot, and people would jump up to block him, and he would just windmill his arm around and just like kind of like lay it in the other way. Oh man, so good. And everyone trying to block him would just be like, "Oh, how did he do it? He's just flying. It's amazing." But how do we solve it? How high did he jump if he was in the air for 1.0 seconds? This is another example. We can make a mathematical model. Of course, the higher you jump, the longer you're in the air. But how do we make that mathematical model? It's pretty tough because there's only two given variables. The equations we know, v equals v naught squared plus 2ad, and d equals v naught t plus 1/2, oh this is squared, sorry, at squared. I guess we also know v equals v naught plus at. You can't solve any of these with only two variables. They all have four variables. The way equations work, you need to have three variables to find the fourth. You need to know every variable except one to find the unknown. But if you only know two, it's not solvable. In fact, it doesn't make sense, because if you think about it, we're trying to find his maximum height that he jumped. Is that the displacement? No, Mr. Lamb. Wow, good job, Hazel. It's not. His displacement for his jump was 0 meters. Problem over. We can't figure out how high you jumped because that's not the displacement. The displacement was 0. So I guess we give up? Of course not. No. Here's what we do. We use our big brains. We can add in one more variable. We don't know his initial velocity v naught. We don't know his final velocity v. But we do know the velocity at the highest point. It's 0 meters per second. It has to be. If it was positive, he'd be going up. If it was negative, he'd be going down. At the highest point, his velocity must be 0. We're going to analyze the first half of the motion and find the height he got to at the first half, the d. It would actually be easier with the second half, but we'll do the first half because it's a nice challenge. The second half would be better. So now it's solvable. We have three variables. 1, 2, 3. This is not true for the front half only. And this is also not true for the front half only. If we only care about the upward motion, well, it's a nice physics rule. It happens to work out nicely if we assume constant acceleration. If acceleration is constant upward and downward, that means he spent the same amount of time going upward and downward. So the time is not 1 second, it's 0.5 seconds. Now we have enough to find the displacement d. And I gotta be really consistent. So I gotta make sure d, yeah, we're good. I just gotta make sure to make a negative. A is downward, so it's negative. D, the displacement, is upward, so we should get a positive answer. Let's see if we do. I'm using this formula because I said so. If you didn't know which formula to use, you could try them all. It'll come out that this one works. Am I using this formula? I was joking. It was all the troll. It was a big troll, and no one ever knew. Okay, we're first using this formula. V equals V naught plus AT. V equals v naught plus at. V, the final velocity at the highest point, is 0. So 0 meters per second equals v naught. That's unknown. We don't know how fast he was going when he jumped off the ground. Plus negative 9.81 meters per second squared. And t is not 1 second. We're only talking about the first half, 0.5 seconds. Okay. I should have probably done this ahead of time. Oh, duh. V naught equals 4.9 meters per second. We got a positive answer. Does that make sense? Yes. Remember, we're only talking about the first half. So he jumped up off the ground. He should have a positive initial velocity. Good job, me. Thanks, me. You're welcome. Now we can solve this formula with this first formula. We can solve for d with the first formula. V, that's 0. V equals v naught squared plus 2ad. 0 meters per second squared equals 4.9 meters per second squared plus 2, negative 9.81 meters per second squared times d. Great. The d is kind of squished, but it's okay. It's all good. And this negative sign, it must be there. You subtract 4.9 squared on both sides. If we didn't have this negative sign, we'll get a negative displacement. We'll say, oh, Dr. J, he jumped into the ground. That makes actually no sense. So I'll solve it right now because I can do so much mental math. 4.9 squared divided by 2 divided by 9. I got positive 1.2 meters. Positive. Did I give away my practice problem? If that was a practice problem, then just make yourself a new practice problem. I'm too lazy. 1.2 meters. That's how high he jumped. That's really high. It might not seem that high, but that's like half. That's more than half his. That's like half his height, and he was super tall. It's not like he jumped over like a fence that was this tall. It's like he lifted his arm straight up, reached as high as he could, and marked a spot on the wall. Then he jumped and reached as high as he could. And when he jumped, he could reach 1.2 meters taller than he could without jumping. That's a very big jump. Yeah. So it was a tricky problem. You have to realize we have to divide this whole time in half, but that's just as long as you remember the rules for gravity, you can solve some pretty tricky problems where as long as you know the acceleration, it's just one given variable. You're just gonna find 3 given variables. If you have 3 variables between a, v, d, v naught t, you can find the other 2, no problem. Is that all I wanted to talk about in this video? I think that's it for now. So, do the practice problems and get ready to become amazing physics scholars. There's some tricky problems in the homework that'll be good practice. I'll see you guys next period for some questions.